All right, guys, if you remember, I told you yesterday that we have like a mid-unit assessment coming today. I want to get us warmed up, though. I want to get us in the right headspace first. And this assessment is going to be open notes, but not open partner. Okay? I will be moving around the room while you're doing it, and if you're really stuck, you're not quite sure what to do or how to do it, we can talk through some stuff, okay? And like I said, you're absolutely allowed to use your notes on this assessment. Huh? No, it's not online. Nope, it'll be on paper. I'll pass it out. So I want to look through these first. This is on page 88 in your book. This is to get us warmed up and get our brains working. So I need everybody's attention up here. I want to look through and determine whether or not these expression pairs are equivalent. What does equivalent mean? Equal. Looks different means the same. If I were to substitute in values, they would give me the same result. So I want to look at each of these pairs. We're going to try to determine first whether or not they're equivalent just by, the structure of the overall expressions. If we get stuck, if we're not sure, or if we want to verify, we're going to substitute some numbers in, and we're going to see whether or not we really do get the same result. On this first one, a plus, and then in parentheses I have 3 minus b. The other expression, I have a plus 3 inside parentheses, and then minus b. So these are exactly the same except for where those parentheses are, correct? Does that mean that I would get the same answer out of both of them, or would I get different answers? What do you guys think? Would it matter if I subtract from 3 first and then I add a? Or if I add a and 3 first and then I subtract b? Does it matter?
Yes.
I've got to vote for yes, it matters. That means that they would not be equivalent. It means I'd get 2 different answers. What do you guys think? You agree? All right, let's try to verify this then. We're going to pick some numbers, anything we want to. Although, that being said, there's usually a couple numbers when I'm verifying that I steer clear of. Like 0, 1, and 2. The reasons for that is because, think about if you do 2 plus 2. What do you get? 4. But if I do 2 times 2, I get 4 that way as well. So those smaller, really easy to work with numbers, sometimes I'm going to get the same result from different operations, right? And what's 1 times 1? 1. Yeah. I'm going to stay away from the really small numbers when I'm verifying these things. Because if it's true, if they're equivalent, it should work no matter what I pick. Give me something, anything you want, that we could put in for A and for B. Give me something that we could put in for A. 6. Give me something that we can put in for B. 12. Sounds good. It doesn't matter which numbers we pick. Like I said, though, I tend to stay away from some of the ones where it's like multiplying and adding give me the same thing, or squaring, or whatever. So 0, 1, and 2 are usually off limits for me. All right, I'm going to take that, I'm going to put that in for A and B in the first expression. So I've got 6 plus, and then inside parentheses, 3 minus 12. Order of operations says to do what first here? Parentheses. So I'm going to do the 3 minus 12 first. What would I get when I do 3 minus 12? Negative 9. Okay, so I have 3 plus negative 9. What is 3 plus negative 9? Negative 6. I'm going to take that same A and B and I'm going to substitute it over here and see if I get the same or different. So I've got my parentheses. I'm putting 6 in the place of A. I'm going to add 3 to that. And then I'm going to subtract 12. 6 plus 3 would give me 9. Hold on a second. What's going on here? Six plus 3 minus 12. 3 minus 12 is negative 9. 3 plus negative 9 is 6. Oh, thank you. I was like, I wrote something wrong here and I couldn't find it. You just found it for me. That was supposed to be a 6, right? My apologies. My brain has too many numbers going on. Okay, so that means I added those things wrong, right? What is 6 plus negative 9? Negative 3. There we go. You ever get the feeling where you're like, I know I did something wrong, but I just can't find it? Yeah. Okay, so I've got 9 minus 12 here. I did add those correctly, right? Okay. 9 minus 12 would give me negative 3. Look different. When I substituted in the values, though, I got the same result. Are these equivalent or not equivalent? These are equivalent. All right, let's look at the next one down. 2 plus k over 5 and 10 plus k. What do we think? Equivalent or not equivalent? If I substitute numbers in, would I get the same result? What do you think? AB, what do you think? This one right here. Equivalent or not equivalent? Do you want to test it? I see some shoulder shrugs. I see a couple of head nods. Okay. How many values do I need to pick out to test? 1. I just need to pick out a value for k. Give me something that we can use for k. 4. Sounds good. All right, so I have 2 plus 4 divided by 5. According to order of operations, what would I do first here? Divide. What is 4 divided by 5 on your calculator? You said 0.8? Calculators are right there. 2 plus 0.8 would be what? 2.8. Over here, I'm going to take 4 and put it in the place of k. But 10 plus 4 gives me 14. Are these equivalent? No. Same input, very different outputs. Not equivalent. What about the one right below that? I have a minus b inside parentheses, and it's being squared. Here I have a squared minus b squared. Do you think these are equivalent or not equivalent? Equivalent or not equivalent? Jose, what do you think? Does it matter? Like, can I distribute the squared like that? How can I know for sure? We're going to try to verify this. I need to pick out two numbers, right? One for A and one for B. Audrey, can you give me a number for A?
7.
7, okay. And Asasia, can you give me a number that we could use for B? 2. I'll allow it this time. All right, so inside my parentheses, I have 7 minus 2 squared. What do I do first according to order of operations? 7 minus 2 inside the parentheses. What is 7 minus 2? 5. After I do the parentheses, then I do the exponent. Dante, what is 5 squared? 25. Okay, let's go check the other expression. Over here I have 7 squared minus 2 squared. Niles, what's 7 squared? 49. Brittany, what's 2 squared? 4. 49 minus 4? 45. Are these equivalent? No. You can't just take that squared and distribute inside those parentheses because of the minus. If it's a minus or a plus inside the parentheses, you can't just apply the squared to both pieces. It changes it too much. So this is not equivalent. What about the one that's way down on the bottom of my screen? 3, and then inside parentheses, z plus w. And then over here I have 3z plus 3w. Is that equivalent?
Yeah.
Yes. What property are you using?
Distribution.
Distributive property, yes. If I distribute here, I get 3z and 3w. This is equivalent. All right, we're going to look at 3 more. Negative a plus 2. And then over here I have all the same numbers and all the same symbols, except I have parentheses around the a plus 2. Taylor, what do you think? Equivalent or not equivalent? Not equivalent. If I apply the exact same distributive property that just worked on the last problem, I would take that negative and distribute it to both pieces. I'd have negative a minus 2, and the other one is negative a plus 2. Not going to be the same. What about this one with fractions here? 1 over x plus y. And then 1 over x plus 1 over y. Equivalent or not equivalent? Jose is shaking his head no. Edgar says no. Fabijas says no. Niles says no. Give me some numbers to prove this to me. What should we put in for x? 5. Give me something to put in for y. 10. That works. I kind of like those. So this would be 1 over 5 plus 10. That'd be 1 over 15, right? Can somebody grab their calculators real quick and just put in 1 divided by 15 so that I know about what this is? I know it's going to be small, but
0.015.
0.06 repeating?
Uh-huh.
Cool. So now for this other one, I'm doing 1/5 plus 1/10. 1/5 is the same as what decimal? Do it in your calculators if you need to. Point 2, 0.20. What is 1 divided by 10? You can do it on your calculator if you need to. What is 1 divided by 10? 0.1. So if I add 0.2 and 0.1, I get what? I get 0.3. Same input, same output? No, not equivalent. Bottom one, x squared plus 4x squared and 5x squared. Do you think these are equivalent or not equivalent? Equivalent? Give me some numbers to prove it. Give me something to put in for x that would show me, that would convince anybody in this room that they're equivalent. 6, okay? So let's put 6 in for x. So I would have 6 squared plus 4 times 6 squared. 6 squared is 36, right? What is 4 times 36?
24.
4 times 6 is 24, but what is 4 times 36? You said how much? 144. So I have 36 plus 144. That comes out to be 180. If I do 5x squared, 5 times 6 squared, I do 5 times 36. What is 5 times 36? 180. So yes, this is equivalent. That first expression, what number is in front of the first x squared? A 1. And they're both x squareds, right? These are like terms. X squared and x squared means I can add my coefficients together. And 1 plus 4 gives me 5. All right. Good job with the warm-up. I want to explain your task to you first, and then I'm going to pass it out. There are 3 questions on your assessment. We're going to be looking at patterns and talking about equivalence. So the 3 questions that are on here. Fred wrote an expression to describe the yellow tiles that are forming the border there. Okay? On this copy, the border didn't show up really clearly as a border. So you might want to color it in on this page just so you can remind yourself of what you're looking at here. Sorry, pass it across. Thank you. It's me up. Give me just one moment. Let me finish giving the directions. I'll be over there. So what I would do first on this page is anything up here that's in yellow, I would color it in a little bit, because that's what this whole thing is talking about. We don't care about the white tiles at all. Fred wrote an expression because he wants to keep making this pattern over and over and over. He's got a boatload of these little white tiles. He's got to go to the store to buy those border tiles, the yellow ones. So he wants an expression that will tell him how many of those yellow tiles he needs to buy. His expression is right up here at the top. 4 times b minus 1 plus 10. Where b is the border number, so 1, 2, 3, that's what the b is in his expression, okay? And if he takes that border number and he puts it in the place of B, it tells him how many yellow tiles he needs around the outside. No matter how many white tiles he's got, it tells him how many of the yellow ones he needs. Your first task is to tell me, why is that expression that Fred came up with a correct expression? It is right. I want to know why it's right. Your second task, the second question. Emma thinks Fred's plan is pretty cool. And she wants to do something similar. But where Fred started with 4 white tiles in the middle, she wants to start with 5. And so she's come up with her own expression for how many yellow tiles she needs around the outside. And you're going to determine whether or not her expression would really tell her how many tiles to go and buy at the store. It might be helpful for that one to draw a picture, model it out. At the very end, Emma is rethinking her plan, and she wants to come up with an expression that no matter how many white tiles she decides to start with, she has an expression that would tell her how many yellow tiles to go and buy. So she's going to use the letter N for how many white tiles she's going to start with. All right? Open notes, not open neighbor. I would highly recommend drawing some pictures and looking for patterns like you did yesterday in that activity before you start answering any of the questions. You have the remainder of the class period to work on this. You do need to turn it in at the end, and it is going in the test category, so don't just sit there and stare at it. If you're stuck, raise your hand, okay?